So this is the 59th session on relative velocity. So in this I take up one problem on relative acceleration problem. Okay. So as we have discussed in the previous videos, if M and F are two frames, M translates with respect to F. P is a moving point. Acceleration of point P with respect to frame F at time t. Acceleration of point P with respect to frame M at time t plus acceleration of M with respect to F at time t. This has already been discussed in the previous videos. Okay, so you go to the details. Previous videos you'll get everything. So I'll take a problem based on this problem. Okay, based on this concept. So the question is this: suppose E1 and E2 are two elevators. Of same height h. And both are initially at rest. E1 and E2 begin to move up and down respectively with same constant acceleration A less than g with respect to ground. With respect to what? Ground. E1 and E2 begin to move up and down respectively with same constant acceleration A with less than g with respect to ground. After certain instant, after some time, two bolts B1 and B2 drop from the ceiling of E1 and E2 respectively. E1 and E2 respectively. Bolt B1 hits the bolt B1 hits the elevator floor after time t1, in time t1, and bolt B2 hits the elevator floor after time t2. Question: two things we have to find. First, find A in terms of g t1 t2. A in terms of g t1 and t2. And second thing, find h in terms of g t1 t2. Okay, two things we have to determine. Okay, fine. Alright, fine. Now I love this. Okay. So I draw the diagram. Okay. See, these are the two elevators E1, E2, both of same height h. This elevator E1, this is elevator E2. Both have the same height h. This begins to move upward at a constant acceleration a. and this begins to move downward at a constant acceleration a. Okay, after some time E1 comes here. Say after time t barabar t say capital say. Suppose after time capital T, bolts begin to fall from two elevators. At t equal to capital T, I'll draw this, okay. See, so this is the initial situation at t block capital T. I'll just draw the diagram again here, just for sake of convenience. See, these are two elevators, okay, at time 0. This elevator E1, this elevator E2. This is at time 0. After capital T seconds later, elevator E1 has come here, okay, at t equal to capital T. Okay, elevator has upward speed of say v1. Now bolt begins to drop here b1. And at time t where capital T, E2 comes somewhere here. And bolt B2 begins to drop from here. E2 has a downward speed of say v2. Okay, fine. The downward speed of say how much? v2. Alright. Now this is going downward at constant acceleration a downward. This is moving up at constant acceleration a upward. Okay. Now bolt B1 drops here and comes to the elevator floor E1. It comes to the floor of the elevator E1 after T1 time, after dropping from this point. And B2 comes here after T2 time, after being detached from elevator ceiling at this time. Okay. Now we'll solve the problem in the frame of elevator. Okay. See, elevator is a translating frame, alright. What we do first, we determine the acceleration of bolt with respect to elevator E1. A B1 E1. A B1 E1 meaning what? Acceleration of bolt with respect to elevator. A B1 E1, alright. Acceleration of bolt with respect to what? Elevator E1. A1 B1 E1. Okay. Now we write like this. Elevator is undergoing a straight line motion with respect to ground. It's a case of translation, rectilinear translation. So A B1G, I'll write here again, is equal to A B1 E1 plus A E1G. Alright. Now A B1G is what? Acceleration of bolt B1 with respect to ground. That is just vector G in downward direction. A B1 A1 is what? Acceleration of bolt with B1 with respect to elevator E1. And acceleration of E1 with respect to ground is what? A in upward direction. Let's call it A1. So A B1 E1 is vector G minus vector A1. It is just vector G plus reverse of vector A1. Alright. I'll rub this one, okay? So A B1 E1 becomes vector G plus reverse of vector A1. Now see, vector G is in downward direction, this is G down. E1 is A upward direction, so minus A1 is A in downward direction. Vectors of these two will be what? G plus A in downward direction. Now A is constant. G plus A is also what? Constant. That is the acceleration of bolt B1 with respect to elevator E1 is constant, equal to G plus A in downward direction. Acceleration of bolt B1 with respect to elevator E1 is constant. How much? G plus A in downward direction, which is constant. So this means now bolt comes from here to here. So it moves with respect to elevator E1, it moves a distance h in downward direction at a constant acceleration of G plus A. So we can apply the formula ut plus half it square to bolt B1 in the frame of elevator. So D barabar is equal to ut plus half A relative t square. This we apply to bolt B1. Okay. Now in the frame of elevator E1, bolt B1 hits the elevator floor after T1 time. With respect to elevator E1, it undergoes a displacement of h in downward direction. So h in downward direction. U is the initial relative velocity of bolt with respect to elevator. at the instant it begins to drop. At that instant, the velocity of bolt with respect to ground is same as that of elevator E1 with respect to ground. So at that instant, relative velocity of bolt B1 with respect to elevator is 0. So this U becomes 0. Plus half A relative is G plus A in downward direction. G plus A in T is the time taken by the bolt B1 to hit the elevator floor, that is T1. So H is equal to G plus A by 2 into T1 square. This first equation which we have obtained. Alright. Now what we have to do? Now we have to consider bolt B2. Now again we determine the acceleration of bolt B2 with respect to elevator E2. So therefore that we write in this way. A B2G, acceleration of bolt B2 with respect to ground, that is equal to A B2 E2 plus A E2G. Alright. Now A B2G is what? Vector G in downward direction. A B2 E2 we have to determine. A B2 E2. And A E2G is what? Acceleration of elevator with respect to ground, that is A2 in downward direction. A2 in downward direction. A2 has a constant magnitude A and directed downward. Okay. This I'll rub it. Okay. So now from this we see that acceleration of bolt B2 with respect to elevator E2 is vector G minus vector A2. That is just vector G plus minus of vector A2. Now vector G is G in downward direction and minus A2. A2 is in downward direction, so minus A2 is in upward direction. So this is A upward. Now see, A is less than G, so resultant of these two will be G minus A in downward direction. And this, since A is constant, this G minus A is also a constant quantity. G minus A is also a constant quantity. Fine. So acceleration of bolt B2 with respect to elevator E2 is constant G minus A in downward direction. Now since it is valid, so we apply the formula ut plus half at square to bolt B2 in the frame of elevator E2. Now when bolt B2 falls from ceiling of elevator E2 to the floor of E2, it undergoes a displacement of h with respect to elevator E2 with initial relative velocity again 0, as was in the case of elevator E1. Relative velocity, because we are applying this formula ut plus half at square in the frame of elevator. So u is the initial relative velocity of bolt B2 with respect to elevator E2. At the instant it begins to drop. At that instant with respect to elevator it is at rest. So initial relative velocity of bolt B2 with respect to elevator E2 will be what? 0. 0 into T2 plus half into acceleration of bolt with respect to elevator, that is G minus A, into what? T2 square. Alright. So H is equal to half G minus A into T2 square. This is the second equation. From these two equations you have to determine A and H. Now H is same, so these two are same. From first and second equation. From first and second equation, what do we get? G plus A by 2 into T1 square, G minus A into T2 square by 2. So 2 and 2 goes away. From this we can solve for A. G into T2 square minus T1 square, T2 square plus T1 square. This is the first answer. Answer the first part of the question. A is equal to G times T2 square minus T1 square by T2 square plus T1 square. First part of the answer. Okay. Now we have also been asked to find the value of H. So what we do is substitute the value of A either in 2 or in 1. Any one of them. Suppose I put it in the first equation. This I rub it. Okay. So I put this, H will be how much? T1 square by 2 G plus A. Instead of A, what do we write? G into T2 square minus T1 square by T2 square plus T1 square. So that is equal to G T1 square by 2 1 plus T2 square minus T1 square by T2 square plus T1 square. So I have this one. Okay. So I will simplify this. g t1 square by 2 t1 square plus t2 square. This also I simplify. t2 square plus t1 square plus t2 square minus t1 square. Now t1 square go away. 2 will go away. g t1 square t2 square by t1 square plus t2 square. This is h. This is the answer to second part of the question. Fine. Till here the relative velocity is finished. Okay. So I have uploaded 59 videos on relative velocity. Okay. So if you go through all of these, you'll be fully conversant with chapter on relative velocity. You'll have full confidence and speed. Okay. If you take any of the problem with JEE Mains Advanced or NEET, you just by seeing it merely will solve it in almost negligibly small time. Okay. So here I close this session on relative velocity. I've made 59 videos on relative velocity. Fine. That's the end of it. Next video I'll take up on rigid body kinematics. Alright. So I close it here.